Welcome back to another World of Level design tutorial. And in this tutorial, I'm going to share something very special with you. I'm going to show you how to create your own custom volumetric cloud material. If you tried to reverse engineer the volumetric cloud actor, the material that's assigned to it by default, you'll find out that it's not that simple to just recreate it from scratch following the given material. And when you go through the material instance properties, the parameters, most of them, they're not very easy to update and change and know exactly what you're changing, since you didn't create the material yourself. So, in this tutorial, I'm going to show you how to create your own volumetric cloud material with all the needed parameters in the material instance so you can tweak the clouds to what you want. Let's begin. First, I highly recommend that you take a look at the previous tutorial, the analysis of volumetric clouds and how to use them. And in that tutorial, I break everything down of what happens when you use the volumetric clouds and how everything is working together. So before you jump in and create your own, make sure you watch that tutorial first, because I cover a lot of the important information that I'm not going to cover in here, because we're going to jump right into creating the material. I will include a link in the description below the video and within the blog post. Let me show you the completed material, the final result. To quickly break this down and give you an overview, the material itself, material domain is set to volume, blend mode is additive, we have a solid color albedo, we then have emissive color turned off, set to 0, we have a cloud texture mask that's being animated for moving clouds. We're then adding that together with a volume texture, which adds the detail to the clouds. And this texture is also being animated for moving clouds. Then we have a falloff function to control upper and lower falloff of the clouds. And that is connected to the cloud texture mask. And then everything is being added together. Then we have a density control for the clouds. And this is being connected into extinction. And then we also have volumetric advanced output node for scattering cloud control. So this is what we're going to create, and I'm going to cover everything step by step and explain what everything is doing and how to set this up. For the test scene, I am using a time of day template. If you go to File and New Level, this is the template I'm using right here. And I have a post-process volume inserted to control auto exposure. And I have exposure, minimum and maximum brightness set to 1. And the entire volume is set to unbound, universal. And I also adjusted the directional light and increased its intensity. I also have Volumetric's plugin enabled to get access to additional content, especially volume textures. And then I have Show Engine Content and Show Plugin Content both enabled. This way we have all the engine content folders and the plugin folders visible inside the content browser. Alright, so now let's go ahead and create our initial material. I'm going to navigate into the folder where I want to create this material in. Then I'm going to go to Add, New Material, and give it a name. I will name mine m_volumetric cloud_tut. And you can name this anything you want. Then right away I'm going to right click on it and create a material instance from it. And I will keep the name that UE4 gives me. Then I'm going to select the volumetric cloud actor and replace the default material with just created material instance. Nothing will happen because our material is empty, and you'll see this halo mirror effect happen, which is normal. So now let's double click on the material and open up the material editor. You want to select the main node, and inside the details panel we need to switch material domain to volume and blend mode to additive. Then I'm going to hold down 3 on the keyboard and left click. This will insert a constant 3 vector. Then right away I'm going to right click and convert to a parameter. This will be our cloud color. And I'm going to change the color of RG and B all to 1 and A or alpha to 0. So this will give us a white color for the clouds. And I'm going to connect it into albedo input. So this white color is everything you need to get started for your clouds. Of course, you can do a lot more complex setup, but at this point it's unnecessary, and you will see that this will be enough. Then I'm going to hold down 1 on the keyboard and left click to insert a constant 1 vector. And I'm going to leave this value at 0, and we don't need a parameter for it. And I'm going to connect it into emissive color. Let's go ahead and save and take a look at what we have so far. We are beginning to have Volumetric Cloud functionality. Next, we need to set up a 2D mask texture. And this texture mask will determine the cloud's shape and where in the sky it will appear. And with the texture mask alone, you will see that you can generate volumetric clouds. Now the texture I'm going to use is inside engine content, and it's going to be this grayscale texture right here. It's found inside engine content, functions, engine material functions 2, example content. And there's nothing special with this texture. It's a simple, small, 128 by 128 pixel grayscale image. It is compressed as mask, no sRGB, with sRGB disabled, with X and Y axis tiling method set to wrap, so you can repeat. And the reason I'm using this simple texture is because of Ryan Brooks. He is a technical artist at Epic Games, and he used a similar small texture mask in one of the streams. And I really liked how easily it communicated what a 2D texture mask does. So I'm going to use a similar approach to communicate this idea. Now you don't have to use the specific texture, you can use any texture mask you want. And I'm going to show you how we swap this texture mask later on to something else. But at this point, this is going to be very easy to see what's happening, and it will communicate the idea of the volumetric clouds a lot better. So I'm going to go ahead, select it, left click, hold and drag right into the material editor. I'm going to right click on this texture sample and convert it to a parameter. This way I'll be able to swap to a different texture mask in the material instance. And then let's set up this texture mask to work with our clouds. First, we need absolute world position node. I'm going to right click and search for position, and it will pop up. So go ahead and insert that. Then we need a scalar parameter. Hold S and left click. This will control our texture mask scale. So I'm going to name it mask scale. And then I'm going to insert multiply. Hold M and left click. I'm going to connect the mask scale parameter into multiply A. Then I'm going to select the multiply, and for multiply B in the details panel, I'm going to enter 100,000. So what's going to happen here is the absolute world position uses centimeters to determine placement of the texture mask. And because clouds deal with kilometers, we need to do some math in order to have our mask scale parameter use whole numbers instead of fractions. Otherwise, we would have to use a very low fraction number such as 0.00001 to change the scale of our texture mask. And UE4 does not allow you to produce more than 6-digit fractions. So that's why we had to multiply to bring the number back up to a whole value, so it's easier to use. If you don't understand what all of that means, don't worry about it, you don't need to. You can just follow and do what I do. But I am going to explain a few things for deeper understanding along the way. Then I'm going to go back and select the mask scale parameter, and let's give it a default value. I'm going to give it 40. Then I'm going to insert a divide. Right click, search for divide and insert it. Then connect multiply into divide B and absolute world position into divide A. Then we need a component mask because absolute world position deals with X, Y, and Z, and a texture mask is a flat image and we need to isolate just the X and the Y. So I'm going to right click and search for component mask and insert it. And I'm going to keep the default values of R and G enabled. R, G, and B equals to X, Y, and Z. Then take divide, connect it into mask input, and the mask output into the UV input of the texture sample. Then on the right side of the texture sample, we need a subtract, and we need a scalar parameter. Hold S and left click. And this is going to be our cloud bias. You can think of cloud bias as influence radius of the texture mask. I'm going to give a default value of 0.2. Then connect the scale parameter into subtract B and the texture sample, the red, green, or the blue channel. And by default, I usually stick with the red channel. And then connect it into subtract A. If you had a packed texture with 3 different masks in each channel, then you would just use the appropriate channel with a specific mask. And I'll show you what that means and how to do that later. But for this texture that we're using right now, for this example, use the red channel. Then I'm going to select everything we've created so far, this entire setup. Left click, hold and drag to marquee select. And then press C on the keyboard. This will create a comment box. And then I'm going to give it a name, Cloud Texture Mask. This will keep everything nice and organized. And before we take a look at what this is doing, we need to create cloud density control. This will determine density of the clouds, how thick they are. So first I'm going to hold M and left click to insert a multiply, and then S and left click to create a scalar parameter. And I'm going to name this parameter cloud density. The default value will be set to 0.1. Then in order for this density to work, I first need to divide it. So I'm going to insert a divide node, connect the parameter into divide A, select the divide node, and inside the details panel for divide B, I'm going to give a value of 100. So we're dividing 0.1 by 100. And if we did not do that, then nothing will happen. The cloud density would not work. And then I'm going to take divide output and connect it into multiply B, and the subtract from our cloud texture mask into multiply A. And then take the multiply output and connect it into extinction of the material. Then let's go ahead and select these three new nodes, left click, hold and drag to marquee select, press C to create a comment box, and I'm going to name it density. Alright, so here's our setup so far. Let's go ahead, hit apply or save or both. And let's take a look at what it's doing and what we have so far. And you can already see that we have shapes for our clouds. And this shape is coming from the 2D texture mask, the grayscale image. And if I go ahead and even fly into this cloud, we have volume of density that you would naturally have inside the cloud. So everything is beginning to work. So this simple setup already provides you with the clouds and the shape. So I'm going to go ahead and navigate back into my folder, and I want to open up the material instance, because now we have a few parameters that we want to enable to change and control. So I'm going to turn on cloud bias, cloud density, and mask scale. You can now begin to change the mask scale, and this will change the repetition of the mask scale texture. If you change cloud density, this will make the clouds thicker or more transparent. And if you change cloud bias, this will change the influence radius of the texture mask. Alright, so at this point you could change the 2D texture mask. So instead of this circle, you would have a more natural organic breakup of the clouds. I'm not going to do this here right now because we need to add more volume, more detail into each shape of the cloud. Because right now it's not really defining what the cloud would actually look like. So for that we need a volume texture. And there are quite a few available with UE4 4.26. And that's what we're going to use. We're going to use what's available to us. The first set of volume textures can be found inside Engine Content, Engine Sky, and Volumetric Clouds folder. And it's these right here. And then when you enable Volumetric's plugin, and then you scroll down, go to Volumetric's Content folder, Content, Volume Textures, Textures. And there are more here. For this example, I'm going to use what's inside Engine Sky and Volumetric's Cloud inside the Engine Content folder. And I'm going to use this T-Volume Noise Shape 128. And at the end of this tutorial, I'm going to swap it for some other ones to show you what the difference is. So I'm going to go ahead, left click, hold and drag this volume texture right into the material editor. We then need to set up something very similar to the 2D texture mask, so we can control the cloud scale. So we need an absolute world position. Then I'm going to create a scalar parameter, S and left click, then name it cloud scale. I'm going to give a default value of 10. Then we need a multiply. I'm going to connect the parameter cloud scale into multiply A. And for multiply B, I'm going to give the same number as I did for the mask texture, 100,000. Again, we're setting up something very similar that we just did above. Then I need a divide. And I'm going to connect multiply to divide B, absolute world position to divide A. And for this, we don't need a component mask because the volume texture works in X, Y, and Z. So I'm going to take divide output and connect it into the UV input of the texture sample. Then over here on the right hand side, I'm going to insert a subtract. Then I need a multiply and another scalar parameter. And this one I'm going to name cloud detail and give a default value of 0.5. Then I'm going to take the red channel from the texture sample from the volume texture, connect it into subtract A. Subtract B will be set to 1, the default. Then take subtract and connect it into multiply A and the parameter cloud detail into multiply B. And then we need to combine the cloud detail setup with the texture mask setup. And to do that, we need an add node. So I'm going to search for add, insert it. Then take subtract output from the texture mask, connect it into add A, and multiply from the volume texture into add B. And then take the add output and replace it, connecting into the density multiply A. I'm going to quickly create a comment box around the volume texture setup. Again, left click, hold, and drag to marquee select. Press C to create a comment box and name it. Now let's go ahead, apply and save, and take a look at what we have so far. Alright, we are already having some detail in the clouds. Let's bring in our material instance. I'm going to enable the two parameters, cloud detail and cloud scale, and then begin to change its values. And as you can see, we are now having more of realistic clouds in the sky. So the combination of the 2D texture mask and the volume texture is the key to creating the volumetric clouds. Next, I'm gonna create a setup for height falloff. This will allow us to change the falloff for the upper shape of the clouds and for the lower shape of the clouds. So this will give a bit of additional control for how the clouds will look. Now this setup is inside the example volumetric cloud material in the volumetric content folder. And also Ryan Brooks did the same setup in one of his streams. So all I'm gonna do is recreate it here for you step by step. But I don't really understand how this is working and what it's doing. So I'm just gonna recreate it and use it because it works. So first we need a cloud sample attribute. Go ahead and insert that. Then we need two multiplies. Hold M and left click. And then we need two scalar parameters. Hold S and left click. The first one at the top, I'm gonna name it falloff upper. Give a default value of 25. And the one on the bottom, I'm gonna name falloff lower. And also give a default value of 25. Then take the first scalar parameter and I'm gonna connect it into the top multiply A. And for the one on the bottom, I'm gonna connect it into the bottom multiply A. Then I'm going to take the cloud sample attribute and only the norm altitude layer output and connect it into the bottom multiply B. And for the top, we need to invert. So I'm going to search for 1 minus node, insert it, and then take the norm altitude layer output, connect it into 1 minus node, and the output of that will go into the top multiply B. Alright, this is what we have so far. Let's continue. I need a custom node. Search for custom and insert it. And for this, we need to do a few things in the details panel. So the code that I'm going to enter is return space exp open parenthesis -x and close it and a semicolon. The output type, change it to CMOT float 1 and description will be exp and inside the parentheses -x. And then you want to open up the inputs, go to 0 and add input name X. And that's going to be our custom expression. Again, I don't really understand what this is doing, but it works. Then take the multiply and connect it into the custom expression input. Then I'm going to duplicate this custom expression. So we have the one for the bottom and it's going to be the exact same thing. I'm going to move it down and then connect the bottom multiply into the second expression. And then we're going to continue and I need a 1 minus node. So I'm going to just duplicate the existing 1 minus and move it over here. And then connect each custom expression to it. And then to finish this off, I'm going to add a multiply. And then connect the top one to multiply A. And then the bottom one to multiply B. Then we need a max node. So search for max. I'm going to change the B value to 0.01. And connect the multiply into max A. Then I'm going to insert a divide. and connect max into divide B, and divide A value will be empty, and the default value of it will be 1. Then I'm going to insert a multiply, connect divide into multiply A, and we're going to create a scalar parameter, and this will be our cloud bias. I'm going to change this value to 0.2. So this is the same cloud bias parameter that is inside our texture mask. And we're going to end up replacing the current cloud bias that's connected for the texture mask with this setup. And make sure to connect the cloud bias into multiply B. So I'm going to create a comment box around it, give it a name, Falloff function, and then we're going to take the multiply output of this Falloff function and then replace it, connecting it into subtract B under the cloud texture mask setup. And this is what we have so far. So now let's go ahead, save, and take a look what this does. Let's bring back the material instance and enable the 2 Falloff parameters, and then begin to change it. And as you can see, now we have control for changing the shape of the cloud on the bottom and then at the top. So it gives you a bit more control. Alright, so far this looks pretty good. We need to add an additional node called Volumetric Advanced Output. So let's go back into the material editor. Right click to search and search for Volumetric Advanced Output. This node provides control over a set of cloud parameters that affect the volume material applied to the volumetric cloud. So basically it will control how light will scatter through the clouds. And as soon as you insert it, it will begin to take effect. So here's the before and here's after. And you can see the slight change. If you select this node, in the details panel, there are a set of properties that you want to take a look at and change. The first one is multi-scattering approximation octave count. By default, it is set to 0, and you may want to change it to 1. So what this does is it affects how light travels through the cloud volume, and it's what will make the clouds bright while also appearing very thick. Now this does add to shader count of the material, so it's recommended that for gameplay you keep it at 0, but if you're creating a non-playable environment, an environment art scene, then you could increase it to 1. And I did find that changing to 1 produces a better result, but 0 also looks good. So here's the default multi-scattering octave count at 0, and here is set to 1. You then have a bunch of other parameters such as phase G, 1 and 2, phase blend, multi-scattering contribution, occlusion, and eccentricity. And they all control additional parameters for scattering light through the cloud. Now you can change them here in the details panel, but of course you want to create parameters instead so you can control it inside the material instance. So let's do that now. I'm going to create a bunch of scalar parameters, hold S and left click, and name them accordingly. First one is going to be phase G, then phase G2, and then phase blend. And the default values for the first 3 is going to be 0. And then for the next 3, it will be multi-scattering contribution with a default value of 0.5. Then I'm going to duplicate, rename. This will be multi-scattering occlusion, also with default value of 0.5. And then multi-scattering eccentricity, also with 0.5 as a default value. And then I'm going to connect them to their appropriate input. And again, you don't have an output for Volumetric Advanced Output because as soon as you have it inside the editor, it will begin to take effect. I'm going to marquee select, left click, hold and drag, create a comment box, press C, and then name it Volumetric Advanced Output. Also, right before we test this out, I want to go through each of the scalar parameters and set a minimum and a maximum slider amount, because there are certain values you don't want to go above or below, and you want to kind of clamp them so they're easier to change. So for the first 2, phase G and phase G2, minimum needs to be set to -1 and maximum is at 1. For the phase blend, minimum should be 0 and maximum should be 1. And then for the bottom 3 multi-scattering ones, the slider minimum should be at 0 and slider max should be at 1. So everything right now is set to default and there will be no change. But now you can adjust and change them inside the material instance. So let's go ahead and do that now. I'm gonna click apply, save, or just save. And then go into your map, bring back the material instance, and begin to adjust how the volumetric advanced output is changing scattering of the light. Alright, another piece of the volumetric cloud material has been completed. Next, we want to add some movement to the clouds. So the first option I'm going to show you is how to move clouds with a manual offset. This is perfect for static scenes, where you want to control movement of the clouds by changing a value, and this is a non-animated method. And then I'm going to show you how to animate it. So let's go back into the material editor, and I'm going to come up to the texture mask setup, and the first thing we need is a constant 3 parameter. I'm going to hold 3 on the keyboard and left click to insert a constant 3 vector, then right click on it and convert it to a parameter. I'm going to name this offset mask. Then insert a subtract, connect the constant 3 parameter, the RGB, into subtract B. Then you want to take the divide from the texture mask, connect it into subtract A, and then the subtract output will go into the component mask. The default values for RGB and A for the constant 3 vector will be all at 0. Then go ahead, apply, or save, or both, and bring up our material instance. I'm going to enable our offset mask, and the only 2 values we need to change are the R and the G. And again, R, G, and B equals to X, Y, and Z. And we're only going to be changing movement of the clouds, the offset, on X and Y. So if you begin to change these 2 values, you will begin to move and change the offset, the position of the texture mask. And you can see that the clouds appear to be moving. So this is perfect for when you have a static scene, no gameplay, no animation, and you want to screenshot. And you want to reposition the mask, the texture mask, to give you a different cloud shape. So I've used this a lot, and by moving it, I can adjust where most interesting clouds happen for my composition in the screenshot. And you can also do the same thing for volumetric texture detail by introducing the offset in the setup as well. And you can actually have both, or you can have one or the other. So to show you this really quick, I'm going to come down to the cloud volume detail setup, insert a constant 3 vector like before, convert it to a parameter. And for this one, I'm going to rename it to a different name, offset clouds. So this way we'll have 2 options. I'm going to insert a subtract, connect the RGB into subtract B, the divide into subtract A, and then subtract will go directly into the UV input of the texture sample, the volume texture. And for this, we don't have a component mask. Not for the volume texture, we don't need it. And then for the default values, for the offset cloud parameter, all will be set to 0. And now back in the map, material instance, enable offset cloud, and begin to change the R or the G, or both. We will begin to offset and change the cloud volume texture and its position. So it'll give us a bit more control and a different offset in addition to the 2D texture offset. So this is great for manually positioning the clouds, moving them. But what if you want to animate the clouds and have them move automatically across the sky? So let me show you how to do that. Let's go back into the material editor. Let's come back up to the 2D texture mask setup, and I'm going to disconnect the manual offset and move it off to the side. To disconnect, you can hold down Alt and left click on the connection and it will break it. So first we're going to set up animated clouds for the texture mask, and then I'll do the same thing for the volume texture. We need a time node. Right click and search for time, then insert a constant 3 vector, hold 3 and left click, then convert it to a parameter. I'm going to name it wind mask. For default values, I'm going to set R and G to 0.5, B at 0, and A at 0. Then let's go ahead, insert a multiply, hold M and left click, then connect time into multiply A, wind mask RGB into multiply B, and then we need to take the setup and we need to add it back into the texture mask setup. So insert an add node, then take divide into add A, and the multiply into add B. And the output from add will go into the component mask. Let's hit apply, back into our map, let the shader compile, and we will have animated clouds. Open up the material instance, then enable the wind mask parameter. And to make the movement speed slower, decrease the R and the G to a reasonable value. Alright, so this method we have animated cloud texture mask. So let's set up the same exact thing for the volume texture. And this will give you a slightly different effect for animated clouds. And I often use both at different speeds to give a more realistic appearance of the cloud movement. So I'm just going to simply take this setup, the time node, the constant 3 vector, multiply and add, Control C to copy, come down to the cloud texture, to the volume texture setup, and Control V to paste. And the first thing I need to do is change the parameter name to something else. And I'm going to rename it to wind clouds. Then take the divide output, connect it into add A, and the add output will go into the UV texture sample input. Let's go ahead and apply. I'm going to re-enable real time, Control R, and bring back the material instance. It's moving way too fast, so I'm going to enable the parameter and change the values to a lot lower number. And adjusting both the wind mask and the wind clouds to slightly different values so they're not exactly the same. We'll move and animate the texture mask and the cloud volume texture. And this will make movement across the sky for your clouds a lot more realistic. The clouds will move across the sky and they will also appear to change shape. And this is how you set up animated clouds in the sky. Now, at this point, we have the same repetition of the clouds due to our 2D texture mask. But now, since we have the cloud shape and detail, and you have the main material already set up, we can go ahead and change the 2D texture mask to another texture. Now, you can do this inside the material editor itself by changing the texture to texture sample. But because we created a parameter from it, we can go ahead and do that inside the material instance. So right now, the reason we see in this repetition is because due to our 2D texture mask. And you can see that we have the sphere gradient, so it's going to cause that repetition. But if we change it to something more organic, more of a noise texture, this will create more natural looking clouds across the sky. So for this, I'm going to navigate into engine content and I'm going to filter by textures. So I can just look at all the textures available instead of having to go into a specific folder. And the texture I'm going to use instead to give you an example of what it looks like when we change it is low-res blurred noise. It's going to be found inside engine content, functions, engine material functions 2, example content, and textures folder. So I'm going to left click, hold, and drag over the material instance and update to the texture. And then I would need to update a few other parameters to make the texture mask tile better. So I just have to go through some of these parameters we've set up to give a more natural appearance. Let's try another texture. And I'm going to use this one right here, offset noise distance fields for normals. And it's going to be found in the same folder as the other one. So I'm going to left click, hold, and drag and replace it. Now don't worry about the actual name. These textures are being used for something within the engine, but they're just simple grayscale textures. And every time you replace a 2D texture mask, you will have to go through your parameters and adjust some of the properties. So the 2D texture mask is very important for making your clouds appear within a certain pattern in the sky. I'm going to quickly reset everything to what we had before. You can also pack a texture with 3 masks, one in each channel, where you have a specific texture mask in the red channel, second one in the green channel, and a third one in the blue channel. And I have an example here that I'm going to use and show you. And this is from Michael Kinsey 3D example files. And I will list a link in the resources to the video, and in there he provides a link to this texture. But it's basically a simple texture with a texture mask packed into each channel. And this way you can have one texture and 3 different masks that you would use to replace for the 2D texture mask as we have already done. So let me show you how that would work. So I'm going to take this texture packed with 2D masks and insert it into the material editor. I'm going to place it over here next to the 2D texture mask setup, and I'm going to replace the grayscale texture we're using. So I'm going to take the component mask output, connect it into the UV sample, and then the output will go into subtract A. Now you would use the channel for a specific texture mask that you want. So since we have 3, you can use the red channel, the green channel, or the blue channel, and they will all be different. So for this example, I'm going to use the blue channel and connect it into the input of subtract A. Let's go ahead, apply, save, then back in the map. I'm going to bring over the material instance, and I'm going to need to adjust the properties, specifically the mask scale, and I need to increase it to a larger number. And then I can adjust all the other properties to make it look good. So you could create your own 2D texture mask or pack 3 different masks into a single texture and use the red, the green, or the blue channel. I'm going to go ahead and replace it back to what we had before. So in addition to changing your 2D texture mask, you can also change the volume texture. Now the volume texture is a bit complex to create yourself. It's an involved process, but you don't need to because UE4 gives you a set of volume textures to use. So let me show you what that looks like and how to use a different volume texture. I'm going to quickly reset everything back to what we had before so you can easily see the difference of what a volume texture will do. And there are 2 places you can get additional volume textures. First is inside Engine Content, Engine Sky, Volumetric Clouds folder, and I've showed you this in the beginning of the video. And another one is when you enable plugin content and you go to Volumetric Content, Content, Volume Textures, and Textures folder. And there's a set of volumetric textures you can use. So I'm going to go ahead and grab this VT Voronoi. I'm going to left click, hold, and drag right into the material editor. And we're going to replace the current volume texture we have. So make sure you come down to the cloud volume texture setup. And I'm just going to reconnect this. So the add output will be connected into the UV of the texture sample. And then the red channel output will be connected into the input of subtract A. Let's hit apply and save. And I actually forgot to replace the red channel of my 2D texture mask and connect it into subtract A. So I'm going to go ahead and quickly fix that. Then apply. Let's go back into our map. Let it compile. And now we get our sky back. So let's go ahead and adjust a few properties. First, mask scale, then cloud scale, then go through the rest of the properties you want to adjust to make your clouds look good. So having a different volume texture does make a difference. Let me use a different volume texture, this Perlin Balanced. I'm going to quickly replace it, reconnect everything to this new volume texture. And actually I'm going to replace the 2D texture mask with one of the grayscale textures from Engine Content that we used before. Then I need to readjust the mask scale, cloud scale, and the other parameters, and just work them to what I want the clouds to look. Then I'm going to turn on the animated clouds, make them move across the sky. Then if you press and hold Ctrl L and move the mouse, you'll reposition the sun and get a different lighting effect, different time of day. And here we are. At this point, you have your very first custom volumetric cloud material. You can now take this material and expand on it. You can use the examples provided inside Engine Content and inside Volumetric Content to see what new additions you can implement into this existing material. To be honest, this already looks pretty good, so you could use it as is. But if you wanted to add additional functionality on top, you now have a good place to start from. So I hope you enjoyed this tutorial. Please give it a like, subscribe, and if you want to learn more about how to use Unreal Engine 4 as a complete beginner so you can begin to create your own environments, I have a tutorial course, UE4 Fundamentals Volume 1, the Essential Beginner's Guide to Getting Started with UE4. And then I also have the second volume that will teach you everything you need to know to begin creating landscapes in Unreal Engine 4. You can download both of these courses on worldofleveldesign.com/store.